Hello, my name is Dale Alexander, and today I'm going to discuss fuel treatment effectiveness on the Nez Perce Clearwater National Forest, specifically the North Fork Ranger District. In my presentation, I'm going to provide a background of the area, discuss some of the objectives of the project, mention the data and models that I use to analyze fire behavior, discuss the weather patterns and methods that I use for inputs, and also mention the landscape and fire behavior characteristics. So the North Fork Ranger District is located in northeast Idaho, approximately 65 miles east of Moscow, and the district is approximately 770,000 acres. Roughly 74% of the district is roadless, so it's very remote, rugged terrain. Much of the district is steep and heavily timbered. It's mixed conifer forest. It consists of species like Douglas fir, grand fir, western larch, hemlock, and western red cedar. Much of the district receives approximately 50 inches of precipitation each year, and parts of the district receive almost double that. So it's a very wet area. Some objectives for the district: they are currently working on the Bernard Junction project area, which is this map over here. The total area is approximately 57,000 acres. And for my project, I broke the different treatments up into 3 categories. I was provided the shapefiles of the various treatments from the AFMO T.C. Peterson. So for the no treatment, I decided that I was going to use that as the base for the project, and these units were burned approximately 1 to 3 years prior, and the treatment 1 and treatment 2 are units that they're looking to burn in the near future. So the total treatment area with all of them combined is approximately 14,000 acres. And some of the goals of these treatments were to mitigate fire behavior for future significant fires, improve the ecological health within the area, return stands to the historical conditions, and improve browse regeneration. The district is home to many ungulates such as deer and elk, so the browse regeneration was really key for them. Some of the data that I used was primarily land fire and RAWS data from the Kelly RAW station. I use those as inputs for primarily Fire Family Plus. This is where I came up with all of the weather outputs. And I primarily used IFTDIS for all of my fire behavior analysis, and I inputted land fire data into the IFTDIS models. The FS Geodata Clearinghouse is what I use to obtain shapefiles for the district boundaries, and I created all of my maps of all of my outputs of fire behavior and ArcMap. I tried using FlamMap for some fire behavior modeling, but I struggled with the model itself. It wasn't as user-friendly to me as IFTDIS, so I primarily stuck with the IFTDIS. So the weather patterns for the area, again, I used the Kelly RAWS data from 2009 to 2019, and I observed weather on a 4-day average to kind of smooth things out. And what I noticed especially was the significant increase in temperature and burning index, and how that was associated with the decrease in RH. And that began right at the 1st of March. But yes, that was a significant increase, which was pretty interesting to me. So that could be a possible area of prescribed burning windows, just right there about March sometime. And then when you get into summer, especially August all the way to September, that is where it peaked out, which is pretty typical for North Idaho. And another window for prescribed fire is right here about the 1st of October is when things really start to decrease as far as temperature and burning index, and the RH is really spiked also. So that would probably be a better window for doing prescribed fire on the district. And with that, over here, the fuel moistures for the district have a pretty similar relationship with the temperature and relative humidity. It with the rise in temperature, the fuel moistures drop significantly right about the 1st of March, and then they trough right about the August 1st of August period and into September, and then again right at the beginning of October they jump back up. So I thought those was pretty interesting to observe and analyze there. I observed some of the wind patterns from 0800 to 1900, and this figure on the left here is the average wind speed. And as you can see, is mostly out of the south and also the northwest, excuse me. And it would be interesting for me to see, to like break up those times of day and see if the winds were predominantly out of the south in the morning and switch to the northwest in the afternoon, or if that was vice versa or whatnot. But judging by the gusts over here on the right from 0800 to 1900, I would assume that the northwest winds were in the afternoon, because typically that's a windier time of day. So for the methods, I used both prescribed fire conditions and wildfire conditions to run my models. And the main things that I changed between the two were the wind speed and wind direction, as well as the fuel moistures. But these were my inputs for my IFTDIS landscape models and the project area models. Some of the landscape characteristics, excuse me, there's a slight typo. So some of the landscape characteristics were the fire behavior field models. The primary ones for the area were TU5 and a GS2, which after I combined layers and analyzed, those seem to be pretty approximate for what I've seen on the ground. I've spent quite a bit of time recreating within the area, and I think that those field models do a good job of summarizing the fuel bed. And over here I kind of discussed some of the non-burnable areas that land fire was producing, and you can see MB9 did a fairly well job of predicting the non-burnables, but they're also missing quite a few spots, as you can see. And NB9s are typically rock or sparse vegetation, things that are non-burnable. The NB8s, however, seem to be pretty accurate. These represent water, and looking at the majority of the rivers and the lakes, seem like the NB8s were very accurate. So some more about the landscape. These pictures over here on the right are some pictures of the actual district and kind of what it looks like. So I feel that these models that I created in IFTDIS pretty well represent what is there. As you can see, the canopy cover is, it varies across a higher percentage level there. And over here, the stand height. A lot of this timber is pretty tall. It's been around for a while. It hasn't seen a whole lot of fire in recent years, so a lot of it's pretty mature timber. The canopy base height I found was interesting, just because that might have influence with crown fire activity as far as ladder fuels go. And the bulk density of the canopy, it wasn't super heavy, but it was kind of right there in the middle. So the fire behavior characteristics for the area, I ran again 2 models, the prescribed fire and the wildfire conditions, and this is for the whole district as well. As you can see, flame length under prescribed conditions was fairly moderate down here at the low levels, and there wasn't too much high flame lengths. As opposed to the wildfire conditions, they had a lot greater numbers of flame length. Rate of spread is obviously much faster during prescribed condition. Wildfire conditions. As you can see, this category down here, the 50 to 150 chains per hour, whereas that's not even represented in the prescribed fire conditions. And the crown fire activity also increased, of course, with wildfire conditions, with a slight active crown fire being showed. So I looked at some monitoring trends in burn severity data for the snow fire, which burned in 2015 on the district, and the files that I downloaded came with a differenced normalized burn ratio file as well as the boundary file. And when looking at the DNBR as compared to this boundary and the aerial imagery, you can see that the DNBR is actually pretty accurate as far as fire severity, especially like right here and right up in here. Over here, you can see that that was much higher burn severity from the aerial imagery, and the DNBR map seems to show that also. So getting to the project itself, this is all of the outputs which I came up with in IFTDIS for the different treatment areas. So again, you have your prescribed conditions and your wildfire conditions, and this was the no treatment, treatment 1, and treatment 2. For flame length, you can see that the treatments obviously have a significant effect on flame length, on the rate of spread here, and especially on crown fire activity. So it's pretty interesting to look and see and compare those. In conclusion, I think that the prescribed fire treatments can be very effective if they're implemented properly. And also, I think the fire model interpretation should be taken with a grain of salt. They're useful tools, but yeah, you kind of need to be careful and not totally listen to what they're telling you, but they do provide you some good data. Some questions that I had was the continuity of the burns. The fire behavior seemed to be very continuous through the treatments, which I had modeled in IFTDIS, and I don't know if that's really the case in real life. It would be interesting to get boots on the ground to do some field observation, and if I had more time, I would like to explore the modeling programs and just all the different variables that go into making all the fire models and seeing how that affects the landscape overall. Thank you, and that concludes my presentation.